All right, so going back into this question, so this one right here, we're looking at this -2 right here. So we got to make sure that we're plugging into the right equation. So what we're doing is we're looking over at this spot right here. We're looking at this and we're saying, does -2 fall into the situation that it's less than 0 or greater than 0? Well, in this case, we know that -2 is less than 0. So when I go to put this in here, I know I'm plugging into the first equation. And let's actually just cover all of them right now. If we're looking at this one's f of 0. So does 0 fall into the x is less than 0, x is greater than 0? Well, we're in this case looking at that equal sign. So it's greater than or equal to 0. So you know you're plugging into this equation because it's equal to 0. So it'll go into the second equation. And that last one, f of 2, well, 2 is definitely greater than 0. So I'm going to also plug that into the second equation. So don't try to plug them into all the equations. Only plug in to one. So in this case, we're plugging -2 into the first equation. So 3 multiplied by -2 minus 4. End up with -6 minus 4, which is -10. All right, f of 0, again, we said we're plugging that into the second equation. So 3 times 0 plus 1. Well, that's just going to give us 0 plus 1, which is 1. And then last, this 2, we're going to plug into the second equation as well. So 3 times 2 plus 1, which is 6 plus 1, which is 7. So, all right, this next one is a weird one. And notice I didn't even give you your own example on this one to try. It's just a strange question. I am not certain we'll even see one on the test, but let's just go over this one just to make sure you know how to do it. It is weird. Basically, they say we have an open box, a box of a maximum volume is made from a square piece of material 24 centimeters on each side by cutting equal squares from the corners and the top. So we've got this square that's 24 centimeters by 24 centimeters, except they're taking it and folding it into a box. So when I fold it, we're losing part of it to make the height. So no longer is this side 24 centimeters anymore because we've used part of it to fold it up. So now it's gotten a little bit smaller, and we got to figure out what's happening there. Below it says the table shows the volume in centimeters cubed of the box in various heights. They showed us what happens if we make make it 1 inch tall, or sorry, 1 centimeter tall. Or if we make the box 2 centimeters, 3 centimeters, or 4 centimeters tall. They gave us all these different variations. So if we come over here and look at the question, the first one's pretty easy. It says, use the table to estimate the maximum volume. Well, the highest number right here is that 1024. So what I can estimate is when the height is 4 centimeters, the max volume is 1,024 centimeters cubed. So that's what's happening. We know that 4 centimeters tall would be the best height if we want to have the biggest box possible. There you go. That looks better. All right, this one though, so B says write the equation. This is where it gets a little bit tricky. We want to write the equation for the volume as a function of the box height changes. And then they asked us to determine the domain. So the first thing we want to worry about is what is the volume of a box? So if you don't remember this from way back in geometry, we know it's length times width times height. So we need to use that formula, meaning we need to figure out what the length of this box is, what the width of the box is, and find a height for the box to be able to create a formula. And again, those change, so we're really looking to figure out what formula makes sense for them. So coming back over here, let's say we choose to make the height x inches. Well, that means each of those little boxes, when I fold them up, is x inches big. X, 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 and x. So what we know is the entire side is 24 centimeters. But if I fold it, we're going to lose those two pieces. We're going to lose this little x right here, and we're going to lose this x right here. Both those x's are going to go away when I fold it. So we know that really the side length is not going to be 24. It's going to be 24 centimeters minus, well, there's 2 x's on each side, so minus 2x. So what I know now is the length of the box is 24 minus 2x. And we know the height is that x that we created. And the length is also 24 minus 2x. You can't really see that there. Put it right here, 24 minus 2x. So when I go to do this formula over here, the length, 24 minus 2x. The width, 24 minus 2x. The height, x. And now I can put that formula in. Volume equals length 24 minus 2x multiplied by the width 24 minus 2x times the height of x. And we need to multiply that all together. So I'm going to go ahead and start by foiling this all together. So 24 times 24 gives us 576. 24 times negative 2 is negative 48x. Negative 2x times times 24 is negative 48x again. And negative 2x times negative 2x is plus 4x squared. All of that still being multiplied by this x on the outside. So one little step, we can simplify this negative 48x and this negative 48x become negative 96x. I don't know why it's not writing there. 96. Weird. Okay, and then we can distribute this x inside, and I'm going to rearrange as I do. I'm going to distribute over to the bigger number first. So x times 4x is going to be 4x cubed. X times negative 96x is negative 96x squared. And x times 576 is plus 576. So that's our formula. Except we need to make sure we think about what the domain would be. Well, if this is going to be a box that we fold, it can't be 0, because if it's 0, then it's just this. It's just a flat sheet of paper. So I know that the domain has to be bigger than 0. So x is bigger than 0. But since we're folding it on both sides, as I keep working my way in, when I hit 12 centimeters, they're going to meet in the middle, and then you're just going to be folding the paper in half. So I know that this also has to be less than 12. So I know the domain is somewhere between 0 and 12 when I go to find the answer for this problem. And again, like I said, I didn't give you an example here because it's just kind of the same exact thing. I guess if you really needed to try one of these for yourself, you're stressed about it, you could change the side length of the box to a different number, maybe say like 18. And you could try to do part B again and see if you could figure it out. All right, looking at number 6. Number 6 is weird because it's got 3 parts. So I am going to ask you to do part 2 and part 3. I'm only going to do the first one here for you. And what I'll tell you about part 2 and part 3, these are actually factoring questions. Actually factoring. I want you to use your factoring rules to do these ones. The first one is not a factoring question. The first one still is factoring, but when I go to factor this, my problem is I try to factor out an x. So I get 4x squared minus 16x plus 2.5. My problem is that when I go to factor this, I don't have any common things, right? If you multiply 4 times 2.5, I get 8. Nope, sorry, that's not right. 10. So I need 2 numbers that multiply to make 10 and add up to make 16. Well, those don't exist. So I'm going to have to use my quadratic formula. Negative b plus or minus the square root b squared minus 4ac over 2a. So I'm going to need to use that formula. In this case, we know this is a, this is b, this is c. So negative b is going to be negative 16, which is just positive 16. When I plug in b squared, 16 squared gives me 256. And then it's 4 times a times c. So 4 times 4 is 16. 16 times 2.5 is 40. And then it's all divided by 2 times a, and 2 times 4 is 8. And now I can just go ahead and put this in my calculator, which is what I'm going to do. And I know you can't necessarily see that, but you could type it in as well and see for yourself. Make sure you're getting the same answer as me so that you know you're doing it right. 256 minus 40 is going to be 216. And then divided by 8. So the first answer I end up getting when I do adding is 3.84. And when I do the same thing, but I subtract this time, I get 0.16. Now the problem is if you rush into it and only select these 2 answers, you would get the question wrong because there's more than just those 2 answers there. You want to make sure you go back and look at the actual factoring question. This gave us the answers for the inside the parentheses, but this right here, this x on the outside, also represents a 0. and it's the 0 at 0. So we got to make sure we include that third answer from that x being factored out in the beginning, and now we've got a perfect answer. All right, number 7 asks us to classify the functions as even, odd, or neither. So I'm going to work through each of these pieces and just look, meaning what I mean by that is if you look at this first one in A, is the x to the third odd or even? Well, the third power is odd. And then I got 1. Remember, this represents x to the 0 power, technically. Well, if you've got a 0 power, is that even or odd? It's going to be even because you can split 0 evenly. So this is even. So I've got 1 odd and 1 even. That means overall this function is neither because it has to be all the same or it doesn't fit one of the properties. In B, I've got an even because it's a power of 2. And then that -3 is a power of 0, so even as well. So since they're both even, it is even. Here I've got x to the 5th, which is odd. I've got x to the 1st, technically, which is odd. Since they're both odd, it's odd. This one's kind of tricky because if you rush into this one, you might get it wrong because you might look at this and say, oh, it's got a power of 1, so it's odd. The problem is this one's one of those weird functions that graph's kind of weird. In fact, if I were to draw a graph of this, so if I draw a graph of the absolute value of x, we know it's going to go up on the right, up on the left. And remember, the whole definition of being even is that you can flip it over the y-axis. And in this case, you could. If you reflected that over the y-axis, you'd get the same answer. So because I can reflect it over the y-axis, we're going to say this is even. Next one, I got a quadratic. This has got an even power to start with a power of 2. This has got a 1 on it, so it's an odd power. And the 8 is x to the 0, so it's also even. So since I've got mixes of even and odd, we're going to say neither. And last, rational functions. Remember, those behave like negatives. If you got even over even, it's even. If you got odd over odd, it's also even. But if you have one odd and another even, then the whole thing's odd. So in this case, if I look on top, I've got an even number or an even power on top because it's a 0 power. On the bottom, the power of 2 is even. Well, even over even means we've got even. Just remember, odd over odd equals even. And then even over odd or odd over even equals odd. Just keep that in mind. And then again, one neither throws the whole thing into a neither. All right, number 8 has us choosing the piecewise function equation that represents the graph below from these 4 choices here. One of the first things I notice is that all the choices, their first thing is the absolute value of x. So I think we can agree that the absolute value of x is probably how we're starting this problem or how this graph is going to look when we start it. And let's take a look at that. If you look over here, it looks like there is an absolute value function. It comes down, and as soon as it gets here, it turns and goes up. And it looks like at that point, this is the spot it changes. So it looks like to the left is an absolute value function. And it looks like when I'm looking on this right side here, this blue part right here, this looks like a quadratic function, like a parabola. And they both have closed circles. So you can see that also the second example does have an exponent of 2, which is signifying that there is a parabola there. So that does make sense. So let's look at where the change happens. If I look right here, the asymptote or the change where the function switch looks like it's at +1. So I need something that says they change at +1. This does not. This does not either because it's got that 0. So it's got to be either A or B because they both have this +1 as the changing point. So our major difference then here is that this says -1 +1 and this one just says -1. So let's take a look at our function. You can see that if this started right here, if the parabola started here, it went left 1 unit, up 1 unit. So I need a function that shows us going left 1 and up 1, and that's going to be right here. I said left. I meant right. Right 1. Sorry. Right 1, up 1. So you can see that this right here stands for right 1. This also stands for right 1. So both of them are good so far. Except this one has the up 1, and this one doesn't have anything at the end. It's not going up or down. So I know it has to be A because it goes right 1 and up 1 on that parabola. For this one, there is a QR code, so you're going to want to make sure you go scan that QR code to find the questions, and you're going to answer all 6 of those questions there and match them to the graphs that make the most sense to them. So make sure that you're scanning that QR code to try that. All right, last page, number 9 says find the domain of each of the following functions. And they gave us a bunch of fractions. Fraction domains, remember, the only thing that we care about in the fractions is that this part in the denominator cannot equal 0. That's it. Unless there's a square root on the top, then you don't have to worry about the top. But if there was a radical on top, then you would address it. But in these cases, it doesn't look like there's any radicals on top. All we got is that on the denominator, we can't have it be 0. So we're going to set each of these equations. X plus 3 cannot equal 0, and x minus 5 cannot equal 0. So in this first one, I'm going to subtract 3, so I get x cannot equal negative 3. And the second one, I'm going to add 5, so x cannot equal 5. And now I'll accept your answers in 2 ways, and you probably want to make sure you know both of them for the test. But the first way you could do is interval notation. So for the domain, you could put negative infinity to the smallest number, which is negative 3, union negative 3 to the next number, which is 5, union 5 to infinity to finish it off. Or you can do that set notation where we go x such that x cannot equal negative 3 comma 5. All right, in part B, again, I got these 2 things on the bottom. I'm going to set both those things equal to 0 and say they can't equal 0, so x plus 2 cannot equal 0, and 3 minus x cannot equal 0. So in the first one, we subtract 2, we get x cannot equal negative 2. But in the bottom, it looks like I'm going to add the x to the other side. That makes the most sense. So it becomes 3 equals positive x when I move this x over here. So x cannot equal 3, and it cannot equal negative 2. So yet again, we've got negative infinity to negative 2, union negative 2 to 3, union 3 to infinity, or x such that x cannot equal negative 2 comma 3. And in this last one, we got to set this part again not equal to 0. But in this case, we've got something that's not factored. So we're going to have to factor it ourselves. So when I take x, I need 2 numbers that multiply to make 4 and add up to make 4. Well, the only 2 numbers that can do that is 2 and 2. So we got x plus 2, which really what that means then is the only thing we care about in the denominator is that x plus 2 cannot equal 0. So that means x cannot equal negative 2. We don't have to do it for the other 2 because they're repeating each other. So no reason to do it again. So what I end up with is negative infinity to negative 2, union negative 2 to infinity, or x such that x cannot equal negative 2. All right, for 10, we have to know a little bit about some business words. So it says the annual cost and revenue for a company from 2010 to 2016 can be approximated by the models below, where T is the year. And they gave us 2 equations. I put this little extra bonus note here to help you. Cost is how much money a company needs to spend to operate. Revenue is how much money a company makes overall. And profit is how much they make when they subtract the cost from the revenue. So in this case, it says write an equation that would determine the profits of a company. We just said profits is if we take the revenue and subtract the cost from it. So take the revenue we made and subtract how much it cost, and that would give us the profits. So in this case, revenue is 341. I'm going to put this in parentheses. 341 plus 3.2t. We're going to subtract the cost, which is 254, minus 9t, minus 1.1t squared. No, sorry, that was plus, wasn't it? Sorry, plus 1.1t squared. And we're going to take this negative sign and distribute it into all this to figure out what's going on. So I've got 341 plus 3.2t minus 254. Negative times a negative is plus 9t squared. Nope, just a t. And then negative times 1.1t squared is negative 1.1t squared. And when I go and arrange this answer to get my final answer, we want to make sure we put some of the stuff where it goes. So I'm going to put the t squared first, so 1.1t squared first. And then my t's, I've got 3.2t and 9t, so those can add together to make plus 12.2t. And then I've got this one and this one, the 2 numbers, 341 and negative 254. So 341 minus 254 is 87. So I'm going to have plus 87 because the positive was bigger. And this would represent our equation for profit. And one last one. The number of bacteria in a refrigerated food is given by this equation here, N of T, where T is the temperature of the food in degrees Celsius. When the food is removed from the fridge, the temperature of the food is given by this next formula, T of T, where T is the hour, the amount in times. So they're asking us over here to compose N of T. So I'm plugging little t into the big T equation and taking whatever solution I get and plugging it into the big N equation. So remember, the way we do this is you take the equation with N in it, or sorry, the equation of N, the first one, this first equation, negative 10t squared minus 20t plus 600. And what we're going to do is anywhere we see a capital letter T, we're going to take it out and plug the equation of T of T in. So I'm going to take that T, and we're going to plug in 3t plus 2. So 10, instead of putting 2, we'll put 3 little t plus 2 squared minus 20, 2 plus 2. And then I've got this plus 600 that's going off at this end piece right here. All right, first thing we got to do, we got to make sure that we FOIL this out. Don't distribute until you've done that FOILing step. So 3t times 3t is 9t squared. 2t times 3t is plus 6t, and then there's going to be another plus 6t, so plus 12t. And then 2 times 2 is 4. And then we're on our distributing step, so we'll distribute everything here. So 10 times 9 times 12 times 4, 90t squared plus 120t plus 40. Distribute the negative 20 over here, minus 60t minus 40. And I got my plus 600 still hanging out over here. And I think I've got some things that cancel. This positive 40, this negative 40 are definitely going to cancel out. So I've got 90t squared, 120 and negative 60t. So 120 minus 60 is just plus 60t. And then we got the plus 600 at the end. So that is the equation we would get to. But it also said that they wanted us to interpret. Sorry, I'm looking in the wrong spot. Find and interpret what this means. So we need to interpret what this means, meaning we probably need to include the domain here. Well, the thing is, the domain is going to copy whatever we started with and then add it into whatever restrictions are here. Well, this piece right here has no restrictions. This is perfect. So all we're going to do is keep the domain from the original, the 0 to t, or sorry, t is between 0 and 6. So 0 is less than or equal to t, which is less than or equal to 6. So it keeps the same domain. And that will be it. So hopefully that helps you out. I'll get the next parts up over the next few days. Let me know if you have any